assessments. So in part 3 here, we'll look at some of the guidelines and limitations for using historical climate data. It is common that the density, the distribution, and record lengths of weather and climate observation network varies considerably within the Nile Basin, just like many other regions in the world. And these can often result in challenges when working with climate data, especially when we want to calculate climate normals, identify long-term changes, and gathering information on extremes to support our climate risk assessment. This is critical. The density and distribution of monitoring networks and stations has been declining significantly over time in the Nile Basin. For example, in Uganda, the number of meteorological stations started increasing in 1952 up to 1980, but then towards 2012, the density dipped down to close to 1952 levels. Same in Burundi, the density of stations has been declining over time. Because of the limitations in climate observation stations, such as rain gauges, in recent years, satellite data products have emerged to fill some of the gaps left behind by gauge stations. For example, we have the GPM, that is the Global Precipitation Measurement Nation, and we have the Tropical Rainfall Measurement Nation. These are all satellite-based data sets which provide graded, consistent data sets across many regions. So they vary. The region of coverage varies. For example, TRIM covers the tropics only, while the GPM covers mostly regions between 60 degrees south to 60 degrees north. There are many data sources, global data sources, which we can use to do climate risk assessments in the Nile Basin. One example is the USA data portal and the Climate Hazard Center at University of California, Santa Barbara has produced this very nice station data set called CHIPS, which is global and can be used for climate risk assessments. It is also important that when doing this risk assessment, we should incorporate traditional and local knowledge. Traditional and local knowledge can provide invaluable insights into long-term local and regional climate, and becomes particularly important in locations with limited instrumental records. And this is key when doing a climate risk assessment and adopting the bottom-up approach to do stress testing of the system. This is where traditional knowledge becomes key. To conclude, overall guidance for using historical climate data sets for infrastructure risk assessment. 1. There are many sources of climate data and information available. 2. Understand climate data limitations and considerations. 3. Always consult a qualified, experienced climate expert to source the right data for you and analyze quality of the data, homogeneity of the data, especially for station observations. Station observations typically have a lot of gaps, and using this data will require that you consult a qualified expert to make sure the data used is homogeneous and representative of the project site under consideration. With that, I will say thank you for your attention.